Hey guys, today I want to review a type of math question that should be pretty simple for most students, but the thing is they haven't talked about it in class or learned about it in a really long time. And like most math concepts on the ACT, the way that they ask questions about this is not always completely straightforward. They put in little twists and changes to make the student think through things that they might not have thought through in a really long time. And this idea that I want to talk about today, or this concept, is called the fundamental counting principle, and that's a really long name for a pretty simple idea, but this is one of those ideas that students really need to understand if they want to get those easy kind of questions that I think they should be getting right every single time. And at first glance, some of these questions might not seem like they're really that easy, but once you understand just the basic math behind them, their simplicity kind of comes through. So what I want to do now is hop over to the iPad, go over a couple of questions that have to do with this idea so we can understand this concept better. Okay, you see here a few examples of the fundamental counting principle, but I haven't even defined what that is yet. So basically, if you were to look this up online, you're going to see something like this, that the fundamental counting principle means if there are P ways to do one thing and Q ways to do another thing, then the number of possible ways to do both is P times Q. So it should be said that if you want to, or maybe you should, pause this video, try out here numbers 2, 3, and 4, and see if you can figure out how to get these questions correct based on what we just said. Now, if you're looking for this and more, you should check out my book, The ACT Math System. I'll link to that in the description. But it goes through these three problems in much more detail and many others as well. All the ACT math that's good to know, all the ACT math that you have to know, and more. So on to number 2. Delaney has X number of movies to choose from. Which of the following expressions gives the number of possible combinations of movies if Delaney desires to watch 3 movies in a row? So part of the difficulty in this problem, of course, is that we don't know how many movies she has to choose from. They just call it X. But one way to maybe get this question correct would be to make X, more of a real number. This is a strategy called picking numbers. You can also find a lot of that in the book that I just mentioned. But when you have a variable, maybe sometimes it's just helpful to change the variable to a real number. So let's pretend that she has 5 movies to choose from, okay? And so now it's saying she wants to choose 3 in a row. Okay, well, we said before that if there are P ways to do one thing and Q ways to do another, that you would multiply the two together. Well, here we're looking at 3 things to do, so like P, Q, and R, if you will. So at first she has 5 movies to choose from, given that we're saying that X equals 5 just out of the blue. Well, if she picks one of those movies, how many does she have left? Well, it's just 4, of course. So if we're using P, Q, and R to represent the numbers for the fundamental counting principle, then like 5 would be P, Well, like we said, if she picks one, she only has 4 left, So it'd be 5 times 4, that would be our Q. And then if she picks one more from that one, she would only have 3 left to choose from, which would be like R. And so in this particular situation, it'd be 5 times 4 times 3, which would be 60. So in other words, kind of taking a step back, if she had 5 movies to choose from, she would have 5 to start, then she would pick one, then she would have 4 more to choose from, she would pick one, then she would have 3 more to choose from, or 60 possible total combinations of 3 movies in a row, given that she has 5 to start. Okay, well again, the question doesn't give us the number 5, it gives us an X. And there would be 2 different ways to solve this problem. Now, one way would be to take X equals 5 and plug it into these 5 answer choice options and see which one gives us the number 60 as the right answer. So that would be one way to do it. And if we did that, we would give, of course, this is 15. What is this? X cubed. So that'd be 125. X plus 1 would be 6 squared. 36 times 5 would be 180. So that's not right either. X cubed is 125 times X squared times X. That's going to be some really big number. So it's not going to be that one. The last one is X times X minus 1 times X minus 2, which would be 5 times 4 times 3, or it would give us an option of 60. For all those reasons, we know that K is actually the right answer. Number 3, the city of Doverville employs 80 police officers and 50 firefighters. The mayor will choose at random 1 police officer and 1 firefighter to represent the city during the 4th of July parade. How many different combinations of 1 police officer and 1 firefighter are possible? This question is based on a real ACT math question that I saw on a recently administered ACT test. And the reason it's kind of tricky is because you have these 4 answer choice options, A, B, C, and D, which are all relatively low numbers. And then you have this one, letter E, which is this big, fat, large number of 4,000, okay? But if we're just thinking about the fundamental counting principle, with 80 police officers to choose from, 50 firefighters to choose from. We're choosing one from each. So this is just simply 80 times 50, or P times Q, to give us the total number of possible combinations of choosing one from each group. So 80 times 50, if you put that in your calculator, you get that it's 4,000. And what the ACD is expecting is that, again, this is based on a real ACD math question, with this kind of a question, is that students are going to get 4,000 and want to select E, but they're going to look at A, B, C, and D and see that those are all low numbers and second guess themselves and go back and choose C or something else. But don't second guess yourself. The math here is pretty simple. 80 times 50 is 4,000. There's 4,000 different combinations of one firefighter and one police officer to be randomly chosen for the 4th of July parade. And number 4, McGregor County issues license plates for all of its automobiles that contain 7 digits. Due to state regulations, the first 2 digits of the plate are fixed and can't be changed. So, in other words, kind of stopping midway through, that leaves us 5 digits to work with. So we're looking at license plates that have seven spaces, but the first 2 are fixed. Okay, so I'm not going to worry about those 2. Due to local law, the 3rd digit is also fixed and can't be changed. Okay, if the remaining digits can feature either one of the 10 numbers 0 through 9 or one of the 26 letters of the alphabet, and if the digits can be repeated, then how many combinations of license plates are possible in McGregor County? So again, these first 3 digits are all fixed. We don't have to worry about them. They don't really come into play at all. That information is just given to make the question a little bit longer. So we have to work with these last 4 places here. So we're told that each of these 4 spots can have either a number or a letter, and there's 10 numbers to choose from, 0 through 9, and 26 letters of the alphabet to choose from. That means for each of these spaces, there's 36 possible either letters or numbers, because 10 plus 26 is 36, that can go in these places. And fortunately, it kind of makes it a little bit easier when the question says the digits can be repeated. Because if they couldn't be repeated, they would have to think the extra step. Well, there's 36, then 1 would go away, like the letter A, for example. Then there'd be 35 to choose from, then 34. So it would just require a little bit more thinking about it to get that question right. But for this question, they can be repeated. So that means we're just dealing with 36 individual digits for these 4 spaces. Well, remember the fundamental counting principle. We're not going to add these together or anything like that. It's simply 36 times 36 times 36 times 36. And if you put that in your calculator, you're going to get 1,679,616. And that's how many different license plates are possible in this county. And that's why the answer number 4 is J. That's it, guys. If you're looking for more, check out my other ACD math videos. God bless.